Hello. In today's brief lecture, I'll address the question of whether C24 is any better than simpler codes such as binary replication codes or binary Hamming codes. I'll compute the reliability of C24 and compare it to the reliability of a comparable binary replication code and a comparable binary Hamming code. Recall that P is a symbol error probability. For a binary symmetric channel, this is a probability that a single bit is transmitted incorrectly. I'll denote the code words of a code C by C1, C2, up to Cm. And I'll let Wi denote the probability that the decoding algorithm makes an incorrect decision or rejects if Ci is transmitted. The error probability of the code C is defined to be the average of these error probabilities. Now, in our decoding algorithms for C24, Hamming codes, and the binary replication codes, the probability that the decoding algorithm makes an incorrect decision or rejects depends only on the weight of the error vector. In particular, it doesn't depend on the actual code word. And so all the Wi's are equal to each other, and hence the error probability of a code is equal to any one of these error probabilities, let's say W1. Finally, I'll define 1 minus PC to be the reliability of the code. This is the probability that a received vector R is decoded correctly. Let's first compute the reliability of C24. For C24, the decoding algorithm will make the correct decision if the error vector has weight 0, 1, 2, or 3. The probability that the error vector has weight 0 is 1 minus p to the 24. This is because the probability that any bit is transmitted correctly is 1 minus p, and code words have 24 bits. The probability that the error vector has weight 1 is given by this expression. The 1 in the error vector can be chosen in 24 choose 1 ways. The probability of transmitting that bit incorrectly is p, and the probability of transmitting the other 23 bits correctly is 1 minus p to the 23rd power. Similarly, this is the probability that the error vector has weight 2, and the probability that the error vector has weight 3. And so this is a reliability of C24. If no channel encoding is used, in other words, a 12-bit source message is transmitted without any change, then the probability that a word is transmitted with no error is 1 minus p to the 12. The exponent is 12 because source messages have length 12 bits. Suppose now that the binary triplication code that I'm calling T is used to encode 12-bit source messages. So each of the 12 bits of a source message is replicated 3 times, and the resulting code word has length 36 bits. When the decoder receives a 36-bit word, it breaks it up into these 3-bit chunks. Each chunk is decoded as follows. If the weight of a chunk is 0 or 1, then that chunk is decoded to a 0 bit. Whereas if the weight of a chunk is 2 or 3, that chunk is decoded to a 1 bit. And so we see that a 36-bit word is decoded correctly, provided that the weight of the error in each 3-bit chunk is 0 or 1. Now, the probability that the error in a 3-bit chunk has weight 0 is 1 minus p cubed. So all 3 bits are transmitted correctly. And the probability that the error vector in a 3-bit chunk has weight 1 is 3p times 1 minus p squared. So the reliability of the binary triplication code is 1 minus pt, which is this probability raised to the power 12. The exponent is 12 because there are 12 3-bit chunks in a 36-bit word. Lastly, let's consider the case where a 1511 binary Hamming code H is used to encode 11-bit messages. I would have liked to select a binary Hamming code where the length of source messages is 12 bits for a fair comparison to C24. However, there is no such binary Hamming code, and so I chose the next best thing, a Hamming code of length 15 and dimension 11. You can check that this is the reliability of the 1511 binary Hamming code. The first term is the probability that the error vector has weight 0, and the second term is the probability that the error vector has weight 1. Here is a table of reliabilities, where the symbol error probability is 0.1, 0.01, and 0.001. This column shows reliability in the case where no source encoding is used. This is the reliability of the triplication code, the Hamming code, and the Golay code. Let's take a look at the last row of this table, when the symbol error probability is 0.001. If no source coding is used, the reliability is 0.988, which means that 98.8% of source messages are received correctly. The triplication code has reliability 0.999964, which means 99.9964% of all code words are decoded correctly. The Hamming code has similar reliability as the triplication code. C24 has much better reliability than the Hamming code or the triplication code. The rate of C24 is 1/2, which is better than the rate of the binary triplication code, even though C24 has much better reliability. C24's rate is a bit less than the rate of the comparable binary Hamming code, but this is compensated with a much better reliability. All things considered, it's fair to say that C24 does a better job of optimizing reliability and the rate compared to the Hamming code and the triplication code.
We're ready now to study cyclic codes, a family of linear codes. We'll introduce the notions of cyclic subspaces and cyclic codes. We'll see how cyclic codes can be characterized as ideals in the ring of polynomials over f modulo x to the n-1. Starting in V5a, we'll be using quite a bit of algebra from the theory of rings and fields. See you in V5a.